Hello and welcome to the today's lecture. So last time we have seen the fuels and the renewable energy sources we have seen. Today we will see the sources which are depleting or which are going to end at one point of time, and these are non-renewable energy resources. The first important one from the group is petroleum and natural gas. So petroleum and natural gas is also termed as fossil fuel, and they are formed under the earth crust after a prolonged reaction on the fossils, the animal and plant tissues, and under high pressure and temperature these fuels are formed. Basically there are gaseous fragment is there, then liquids, and then the asphalt is last, which we use for making roads, tar what we call it in common language. The crude oil which is obtained by different sources. For example, Bombay High, we extract the oil from the sea bed, and that is a crude oil which is contaminated. A brine is there, so separation technique is there, refining is there, and after refining you get various fragments like naphtha, kerosene, diesel, heavy oil, asphalt, and lastly the coke. Now these refineries are important because they will bring about the purification of the various fragments. So we start with naphtha, or we call it as gas, then aviation fuel, then octane, that is petrol, kerosene which is also termed as jet fuel, diesel, heavy oil, and all the remaining things are there. The refineries are normally located at the coastal area because the sources of crude oil are nearby, so the transportation is less costly. And after refining, now there are some underground lines from where these purified products are supplied, or else you must have seen the big vehicles carrying this gas and petrol, diesel, etc. Now refining operations can be divided into 4 parts. Fractional distillation, in chemistry we call it as like if the boiling points are close, then we need a fractionating column, and fractional distillation is done so that you get the fragments according to their boiling points. For example, petroleum ether has got 2 fragments, 60-80, that is one fragment, and 120 plus, that is another fragment. So even petroleum ether has got 2 fragments. Conversion process, now heating, alkylation, isomerization, these are some of the steps involved. The catalytic breakdown of petrol into butane is a well known process. So wherein the natural gas what we get is normally methane with some other small carbon 2, carbon 3 units gases, and that is one of the source. Now liquefied petroleum gas is another thing. Now treatment, removing aromatics. Now aromatics means when you go to the higher heavy oils and asphalt and all. So asphalt has got some aromatic compounds like naphthalene, quinoline, which give awful smell. So all those things are needed to be removed from the crude oil. And physical separation means filtration, decantation, etc. And then heating and drying just to get rid of some moisture if it is there, and heating is obviously there because that will lessen the viscosity of that crude oil and the separation becomes easy or fast. And last is formulating and blending. So blending means you can add, like here blending refers to addition of ethyl alcohol, because that blending to petrol is generally recommended worldwide, and we know that in Brazil they use about 25% of ethanol blended in petrol, so that the cost of petrol goes down and ethanol can be produced by so many processes, mainly from the sugar industries, cane sugar, beet sugar, maize, other sources are there. So you can get the ethanol, and that blending can reduce the overall cost of the fuel or that petrol for that matter. Now these refineries are there. The sources or where we get the fossil fuel or crude oil in India, one is Bombay High, as you may be knowing, second is Godavari Basin, and third is Dibrugarh, Assam, wherein you have got the deposits, and now they are the ONGC is working on other sites also, because that is the main objective of ONGC, to find out the sources and then work out the process for removing them and then supplying it to the Indian citizens. Okay. Now that is regarding the petroleum and natural gas. One more component which is important, and that is coal. Now coal mines are there. So coal mines, the grading is there as per the carbon percentage: anthracite, bituminous, subbituminous and lignite. Depending upon the carbon content, the anthracite is supposed to have the highest calorific value because it has got high carbon percentage as compared to other coal, and we know that the thermal power stations which are located at Chandrapur, they are making the use of coal, and the electricity is generated through the coal energy, thermal energy. Coal is heated and that heat is used for running the turbines, and finally the electricity is produced. So that thermal electricity is also produced by that method. Now coal, the only problem is it can lead to environmental pollution, and recently the Pollution Control Board has kept some fine on the thermal power stations located at Chandrapur for violating the environmental norms. Now this is one part. Second part is nuclear reactor. Now nuclear energy can be used for the benefits of human being. So wherein your nuclear fission energy is used, and that is used in controlled manner, and whatever coolant you are using here in the reactor, that coolant gets heated and that steam or the energy goes to turbine and then electricity is produced. Now, regarding nuclear fission reactions, we know that these are the natural isotopes uranium-235 and uranium-238. Uranium-238 has got the highest T-half period or half-life time, you can say 4.468 into 10 raised to 9 years. So, if I start with 1 gram of uranium-238, it will take so many years to become 0.5 gram. So, and that is a source of neutron, and then the chain reaction, as you are aware, is a cause for it produces tremendous heat, and if it is controlled, the graphite moderator is there. Now, moderator's job is to control the chain reaction and keep it at normal rate, so that it will keep on taking place and it won't be out of control. So, this is controlled fission reaction, and these are the natural resources. In India, we have thorium, which can be transformed into uranium-233 isotope, which is fissile. That means it has got the half-life period, and that is a fuel for nuclear reactor, and or it is also termed as breeder reactor, and you get the energy and ultimately the electricity. Now, if you look at the nuclear fuel energy worldwide, it is around 10%. The main is coal, that is 37%, natural gas 24%, hydraulic is 16%, nuclear is 10%, solar is 3%, and other sources 5%. Other may be wood, burning wood can also provide an energy. So, that is also another source. Okay. If you look at the newer fuel, CNG you must have seen, compressed natural gas, that is one of the fuel. Then electrical vehicles are also coming in market, where the battery is there and that battery supplies energy to engine. And another thing is hydrogen fuel cell. This is the hot topic now. Much research is going on this, because here hydrogen and oxygen, they react to form water, and the current is passing through the circuit. Cathode and anode is there, and this is the chemical reaction. So, this is hydrogen fuel cell, which the only problem with this is hydrogen is highly inflammable. So, handling in a vehicle, normally this is used at many places, including motor cars. So, this is going to be a challenge, because there has to be a safety measurement for this. Another one more fuel which I will mention here, that is biodiesel. Biodiesel is another source wherein we can get the fuel which can be used for running the vehicles, two-wheelers, four-wheelers, etc. And biodiesel is nothing but the methyl or ethyl ester of fatty acid, and generally they are obtained from the vegetable oils, either edible or non-edible. So, that biodiesel is now fatty acid ester of long chain. So, C14, C17 fatty acids are there, and the best example I would say the non-edible oils like castor oil. Castor oil can have medicinal uses, but we cannot consume that. So, that can be transformed into methyl ester and methyl ethyl or propyl ester, and that compound itself is a biodiesel. Now, this can be blended with normal diesel, and those blends are given as B5, P20, B100. So, B5 stands for 5% biodiesel in diesel, B20 is 6 to 20% and B100 is the pure biodiesel itself. And now the advantage of biodiesel is this compound has got higher cetane number than diesel. So, in petrol we say octane number, in diesel we say cetane number, and it gives less emission of gases because it is obtained from natural resources. Of course, it does not cause any pollution to the atmosphere, and that is why these are blended in your classical fuels, so that you can get the better blend to operate with. Okay. These are some of the important fuels. Now, beside this, some rocket fuels and all they are there, but rocket fuel is generally mixture of a combination of oxygen and hydrogen gases. So, they form water, and that energy is pushing the rocket upward, because that rocket propellant fuel, what they call it as, so that is gases. There are solid fuels also, some perchlorates are there, they are solid fuels, but will not talk much. Of course, I have got some notes also, I will be sharing those notes on the WhatsApp group or our Google Classroom. Can go through them, and finally from students perspective there will be around 5 questions from fuel topic in your final exam to be conducted on 31st. So, just revise the things. I will put the notes also. Once the lectures are done, immediately the study material I will be sharing with you, and you can use them, use the material for getting the best mark in your credit course exam, because that is going to be mandatory according to SPPU. Okay. Thank you very much.